create a class. Then we declared how to declare methods and how to return a value. And we also had some idea about what is instance variables, what are instance methods. Now, today, let's jump to the next topic, which is what we call static concept, static variables, static methods. So let's discuss this. So when you say static, what is static variable? You can see here. And then where should we declare static? And what happens when we declare static? All this we are going to talk in today's session. Okay. And also in the process, we might get a clear idea what are instance and what are instance variables, instance methods. Already we know that, but a little deeper understanding of all this. Okay. So now, mm, static variable. Now let's start this. Let's just we'll just make it simple. Let's not okay uh, try to go too deeper. Whatever that is needed to understand this, we'll do that and then jump to the next topic. Now coming to this static variable. What does this static variable mean, sir? It's simple, friends. It is a variable declared using a keyword static is known as static variable. Okay, and then usually if you talk about static variables, let me just show you. So static means simply speaking, these are declared with variables and methods and inner classes if you want. There is something called inner classes, not outer classes. Excuse me. Or top level classes or regular classes, because we cannot declare classes as static except inner classes. Okay. So this is where we can apply static keyword. When you say static variable, simply speaking, right, this is static variable. We declare a variable, suppose this is int a, sum that 10. And before this variable, you declare this as static. This is static variable. That's all. If you declare a keyword static before some variable, this becomes a static variable. Then what is the difference between normal variables and static variables? It's so simple. If it is generally in a class, we have two types of variables or two types of members inside a class in Java. A class has instance members. We have more of this. We have many instance members and few static members, and then static members. Okay, these are two types what we have. Instance members means what? All that variables we have seen. Non-static variables inside a class, non-static methods inside a class are instance members. Everything non-static, which are not static, whatever we have used so far. If you see in this program, right, you can understand now. These are all non-static variables. So these are instance members. These are non-static methods. These are instance members. By default in a class, if any variables are non-static or and if any methods are non-static, they are instance members. They belong to object. I have explained with tracing yesterday. These are part of object. And now coming to this static members, right? These are static members means these are static, and these doesn't belong to object. Static members are not part of object. Like static variables are static methods. They don't belong to object. They are part of class. I'll show you an example so you can easily understand now. So let me show you a quick example how to declare static variable and static method. Right. So what we do is I'll take a small example now. Right click, new, and then class, and then what shall I say? You can take a static demo. So you get a clear idea now. Okay. And then say take a simple class some test or something you can take, no problem. You can put main inside this. Now declare few variables here. Test is already there. That's why we have another one important point for you. What is it? In these classes, in this package, if you declare anywhere this class test, then it doesn't allow you to declare that class here. Even though this file is a different file, if this class already exists somewhere, then you have it doesn't allow here probably. Let me show you. You can see here, it is saying the type test is already defined. And by this, you can easily understand. This is a small tip for you. Maybe you can add it. Okay. So remember it. So make sure that these classes are defined only for one time in your package. Maybe in another package, you can define another class. But within the same package, a class is allowed to declare only for one time. Okay, that's why this error. I put test one, no problem. Test one is also there, seems like. So two, right now this is okay. So what I do now, I declare a static variable like this, something like static. I'll just show you here. Static sum int a equal to 10. So this is a static variable. So how can I say this is static? By looking at it, you can easily understand this is what, friends, this is a static variable because we have static keyword before this variable. Right, next one. So that's all about this. And here, what is difference between a normal variable and static variable? I'll just give a quick idea. So what is it? If it is instance variable, so here we have a separate copy for each object. You create 10 objects, there will be 10 copies of instance variable. Suppose you say int a equal to 10, which is instance. And you are creating multiple objects for some class. Suppose you say for test class, you have two types here now. I say int some x equal to 10. And then int a equal to static int a equal to 10. Now in this program, if you see for this program, a quick idea. So the difference is I create multiple objects for test1 to some t1 equal to new test1 to runs is simple. Okay. And then again, of course, remove this. There is a small typo. You can remove this. T2 object 2. Similarly, if I create one more object, okay, test1 to T3. Now here, when I create three objects, we have each object has one copy of X. Means we have three altogether we have three copies of X. One copy of X for T1, one copy for T2, one copy for T3. So here instance means there will be a separate copy for each object we create. But static is not like this. For all these objects, you have only one copy. This is a global copy. Okay, friends. So this is clear, right? Let me show you quickly. Let me debug and show you. You get a clear picture now. Right click and then put a debugger somewhere. Okay, that just to test your code. And then debug as Java application. Okay, run this. Proceed. Now, if you see here, now you can understand here from here, right? when you start executing the code, just a minute, I think there is a small typo. Yeah, let me remove this now, save this. Okay, now you can just test it one by one. So we put a this one here. One minute. Let me. Okay, now you can see it all started here. Okay, let's run one by one. Step over. You can see when I say step over, one object is created, T1. Inside that, you can see one variable X, which is initialized to 10. Again, step over. Another object T2 is created. Inside that, you can see X again. Again, we have moved to T3. When you see move to T3, again, one another object X is created. T3, sorry, another variable X is created. If you look at this, once this program get executed, three objects are created. Each object has one variable X, X, X. There is a, you can see this. We have a copy of X for each object. T1 has X, which is set to 10. T2 has X, which is set to 20. T3 has X, which is set to 10. This itself gives you a clear idea. If it is instance variable, there will be a separate copy of variable for each object you create. But if it is static, you don't see the static variable anywhere inside these objects. If you observe the static variable, you don't see that this A is not present in T1 or T2 or T3. This itself gives you a clear idea. Static variables are not part of object. They don't belong to object. They are part of class. This itself is a clear proof. You don't need anything. If you look at this window, this is clearly showing you objects. So the creation of objects and also the variables inside each object. And these variables which are part of object, we call them as instance variables. Got it, friends? This is a clear picture. Okay, and whichever this static is not part of these objects, so these are not instance. These are class variables, what we call. So why we call them class variable? Because they don't belong to object, but they are part of class, and we can call these static members directly using class. I'll just show you now. See here, if I want to call X in this main, I should call them only through reference. Why? They are inside these objects. So I can call this X like T1.x and T2.x and T3.x. But this A, I cannot say T1.x, but we should not actually. Even if it is allowed also, we should not. Generally, the recommended is you should call these static members with class name. Let me show you. So here, T1.a, just a minute, friends. Oh, sorry. I was talking on mute, friends. Sorry. If it is an instance member, then how should I call this instance members? Using reference always, you can see here T1 or T2 or T3. But if it is static variable, excuse me, if it is static variable, we can call them only with class name, or at least suppose you see here system dot out dot println. Let me just show you. Suppose you can say t1 dot x. This should be fine. I'm able to call with the object. Now you don't see any error. Let's run this first. Right click, run as Java application. Now you can take the value of a different. Let's I'm terminating debugging. I'll come back to that again. Right click, run as Java application. Now you got, the value of a is 20, the value of x is 10. So now we are printing, oh, x is instance, right? Sorry. And then this one is a static. Let's be like that. Now right click, run as Java application. So now if you see, these are all instance variables. First three values are coming from this instance variable x, x is part of each object separately. There is a separate copy. This A is not part of object actually. Even though objects are able to call this A, this is an instance variable, sorry, a static variable, and this is not part of a object. If you see, it's not part of T1 or T2 or T3. It is a global copy. And here only we have one copy of static variable. We don't have like three copies like how we have for X. X is three copies, one for T1, one for T2, one for T3. But this is A is only one copy. How many copies are there? Just one copy. If it is a static variable, one copy of variable is created and shared by all the objects. It can be shared among objects. That is fine. But it doesn't belong to class. And this is not a recommended way to call a static variable. You say, right, reference dot a is not recommended. Then how to call static variables? Generally, we should call the static variables using class name. Let me show you like this. Test12 dot a. Okay, test12 dot a. So this is how we should call a static variable. These are all very useful observations. How to call this like this. Following friends, how to call static variable using class name dot variable name. This is a recommended way. I did in the previous case. I called this static variable using a reference. That is not actually a right way or not a standard way, a recommended way. You should not call like that. Usually static members should be called using in a static way. Static way in sense, we should call it using class name like this, like this. Now, if you see, if I run this program, right click and then run as Java application, you get the same output. We don't see difference in the output, but there is a difference in the way we access this static member. So point is, what is that? Don't call static members using references. Call it with the class name. Is this clear, friends? Now, by now it should be clear for you. I hope you should be able to understand this, right? So let me summarize these things now. What is static member here? Declared using keyword static. Point two, if it is static variable, generally where can we apply this static keyword? We can apply the static keyword with static variables and with variables and methods, simply speaking, and inner classes. Inner classes, we'll talk about it later. For now, let's focus on static variables and methods. So the static keyword can be applied with variables, methods, and classes. Now I'm talking about static variable and static method. Already we had discussed about static variable. What is static variable? It's nothing but declared using keyword static. Already we had discussed here the example. So if a variable declared using keyword static like this, it is static variable. And what happens with static variables? So if point one, I'm just summarizing this. What is static variable means? declared, okay, using keyword what friends? Using keyword static. That is one thing. And you know the syntax already. So just put static before that variable. Some data static space, data type space, variable name equal to some value if you want. You can assign some value. So this is the syntax for declaring static variables. Okay, this is the syntax. Next after that, maybe if it is a if you declare inside class, then this can be what? This can we can also have access modifier if you want. Right. This is about static variable, syntax of static variable. Okay. Next one. Then another scenario we have already seen an example now. This is syntax. Okay. Next one. Example. What is the example here? Some static int a equal to 10. This is an example. Already we have used a small scenario here. Okay. Next, if you want, you can put public also. Public static, excuse me, friends. Okay, public. You can also apply access modifier. Here, this is static variable. Okay, and what happens if you declare what is difference between instance members and static members? So you see, in this program, we have instance variable, we have a static variable. What is difference? So simple, friends. If it is static variable, means what happens here? Only one copy of memory is allocated for static variables. One copy of memory is allocated for static variables and it is shared by static variables and shared by all other objects. All other objects. And these doesn't belong to object. Simply speaking, these don't belong to object, friends. Which one? Static variables are static methods. They are not part of object. Are you following, friends? So another important point is here we have only one copy of static variable, unlike instance. If it is instance variable, we had clearly observed with debugging, there will be a separate copy of instance variable for each object. If you have 100 objects, 100 copies of instance variables exist. But how many static variables exist? How many copies of static variables exist? One copy of static variable exists. Maybe if these objects want, they can share this object. Sorry, they can share this static variable. So one copy is created for static and it is shared by objects. That's all. It is a shared variable. This is not something specific to object. These are all the static variables are shared variables. This is not shared. This is something specific to each object, instance variable. So that's the point here. How many copies are here created for static variables? One copy of memory is allocated for static variable. Okay. And it is shared by all the objects. That is one thing. Next one. So that's why these are called shared variables. Keep in mind. But for instance variables, how many copies exist? There will be a separate copy for each object. And last point, we invoke static. We generally recommended way to call static members, variable or method, is through class name. We invoke means call static variable or method using class name. That's why from this example, you can clearly understand. You can clearly understand. You are able to call this static variable using class name. Directly using class name without creating, or you don't need objects for this. Let me just show you. I'm removing all this just to make it more clear for you. There is no object this time. And we have instance variable and static variable. If it is static, I'm able to call this static variable directly without creating object. You see, I didn't create any objects, right? Let's say right click and then say run as and Java application. You can see 20 is printing. Can you try that same for X? Do that for X. You try to call this X prints. You cannot. It's impossible. X is instance variable, and we can call this instance variable only by creating object. Without that objects, X doesn't exist. Is this clear? Like quick example, maybe if it is just to only understand. If you want idli, before that, what is that you need? You need that idli cooker. If you want to cook that idli, best example, simple and easy to understand. Your idli is a instance variable. If that should be prepared, before that idli vessel must exist. That is your object. You got this point, friends? This is a quick idea, a quick example. Same something like this. Understood? No? So here, instance variables, if idli must exist, because I am from South India, I am taking this idli example. Before that, cooker must exist. I think this is clear for you. So here, for instance variables, if I should call this, if I should invoke this, before this object must exist. But if it is static variable, I don't need that. I can call it directly using class name. This is a simple difference between both. These are all important things. So I'm just trying to emphasize more here. Okay, that's why we invoke static variable or method using class name directly and directly without creating objects. Remember this. So what is the advantage of this approach? What is the advantage here, friends? If you don't create object, generally, wherever you avoid creating objects, means it is going to save memory. But this is not recommended always, because we need instance members, we need more objects compared to static members. So the usage of static variables or static methods is limited. They are not used rigorously every time. Like how we use instance variables or how we use instance methods or objects. Got it right? So, but this is the point. Whenever there is a possibility, if you don't want to create object, if we can avoid creating objects, then it is going to save a lot of memory. That is when you choose to declare variables as static or methods as static, so that we can avoid unnecessary wastage of memory. So I hope this is clear for all of you. How to call static variable or method directly, method using class name directly without objects. This approach saves memory. This is going to save memory. But this is not always possible. Wherever it is possible, then we should apply them as those variables as static or methods as static. Maybe if you want, I'll give a quick example. All this, utility methods, what we call. If you look it into math class, you can check in a math class. Let me just show you all methods of math class. Let me show you. You can easily understand math dot. So most of these methods are static. I am not seeing that as static thing here, but these are all static because you can see when I say math dot, this is a built-in class which has all mathematical methods. Without creating object, I am saying math.e, math.py. I am able to call all this directly without object. Means this itself gives us a clear idea. What is that? These are all static members. I hope you understand this. So there is a lot of advantage here. We avoid so much of memory. So we save so much of memory here, right? This is a quick idea about static variable and what happens, how many copies of memory exist for static variables, and then is it part of object or class, and how do we call it, and what is the advantage if you declare static variable or method. That I think this should be clear for all of you friends. Now next scenario is static method. So again, another one more. You can declare a method as static. Hmm. Static method. Static method means simple. What is static method? It's so simple. You declare a method as static by using keyword static. That's all. Okay. So what do you do? Static methods means methods declared using keyword static. Simply speaking. Right. We'll finish this quickly. Methods declared, and observe this carefully. This is going to this scenario. If you listen and concentrate carefully, friends, this is going to help you to understand many things that were underlying in your Java. Underneath many of these scenarios, this static concept exists, including your main method. Why it is declared as static? If you want to understand, then this discussion is going to clarify those all those questions. So first thing, what is static method? Static method means a method declared using keyword static. Using static, that is one. Number two, syntax means what? How do you declare syntax? A simple, friends. Something like a access modifier, because all these are inside class, so we can declare them with access modifier. Static, generally, if it is static method, you have to use static. And then return type, if it is a method, the method should have return type and then method name and then parenthesis and then body. And this is syntax of static method. I hope this is clear for all of you friends. And these two keywords, you can interchange it if you want. You can say static access modifier, static public or static protected, like that. Okay, you can interchange this, right? So it can be public static void some m1, or it can be static public void someone. So you can interchange access modifier and static, no issues. But this is the syntax. Is this clear for all of you friends? Example. Let us take an example. Simply speaking, some you can ignore access modifier. It's not like you should declare. We already discussed. If you don't declare any access modifier, then by default there will be one access, that is default access. Just remember. I'll talk about it maybe today itself. Public static void some m1. This is simple syntax, simple example for a static method. Usually static methods do return some values. Okay, because we declare utility methods as static. Utility means which carry out some business logic, some mathematical logic, some database logic. So they have certain logic inside that which returns some values at the end. So usually static methods we will not be void. They will be returning something. So it might be int or float or long or byte or short or something. Okay, but this is the example, friends. I hope this is clear for all of you. What is the example? Public space static. Just before method, just put the static, friends. It becomes static method. Again, you might ask a question. So, Manoram, what is the difference between instance methods and static methods? See, instance methods will, again, when you say instance, object has to be in place. First thing, before instance method, that object should be created. Before instance variable, that object should be created. I hope this is clear for you. Excuse me. Means what, friends? Inside a class, you declare a method like let us take an example and let's have a clear idea. And you will understand so many good things here. So now you are clear, right, friends? So we had discussed about the static variables, static methods. Okay, all this stuff. Now, an example for static method is this. Let's see. with a small program the difference between static methods and instance methods. First, let's understand static methods. Some public static void M1. This is a simple example. And here, just print this static variable inside this. So the value of A is plus A. Okay. Now this time, if you see, now already we have some understanding. We know something. If if this one, what is this? Is it static variable or instance variable? Definitely this is a instance variable. Why? Why, friends? Because in a class, anything non-static is instance. And inside class, we can have only two types of members. Instance and static, that's all, nothing else. Right? Similarly, here, when you talk about method, right? This is a static method again. So, and this doesn't belong to class. Sorry, this is not part of object. When I say this statement, maybe you might ask a question. What is not part of object? You are confusing us, Manoram. Simply speaking, when something is not part of object, or when something is part of object, easily to differentiate these two is if something is part of object, before we call those members. For example, let me take one more small example to differentiate without wasting much time. Public void some M2. You take M2 as instance, M1 as static. Now in this case, this is an instance method, right? Instance method. You understand within next few minutes a clear picture, a clear difference between instance members and static members. Instance method. Okay. And this is a static method. And this is a static variable, right? By looking at that itself, you can easily understand, but I'm just giving a comment. Static variable. That's fine. So now the difference is if it is the static method, I don't need to create object to call this. If it is a static variable, I don't need any object to call this. Now you see here the example. At line 21, I am able to call a static variable without creating object. Similarly, I can call this static method without creating object. Like if you see here, test12 dot, you can see on this class, if you observe carefully, when I say test dot, that class name, on class name, you can see only two members. One is A, which is static variable. Second one is M1, which is a static method. But I have still X and M2. I am not able to see that X and M2 on this class name. Why? Because those are instance members are not part of class, but they are part of a object. But static members are part of class. That's why when I say class name dot, I am able to see A and M1 here. That itself is a clear proof. Static members belong to class. They don't belong to object. Proof is see here. This is a clear proof. When I say class name dot, you can clearly see that that method and that variable which belong to that class. By this, we can clearly understand static members are in class scope. Which scope, friends? Class scope. Very clearly, I'm saying this. Then you can ask, how about instance members? Instance members means only after creating object, something like test1 to t1 equal to new test1. If only after saying new space test12, then this instance members exist. Till that, no instance members. Like best example of idli. Without idli vessel, idli cooker, you don't get idli. You can't prepare it. Okay, maybe if you come up with, sir, Manoram, I might choose some other vessel to do that. See, I'm just giving a quick example. Okay, I'm not. Let's not go too deeper into that thing. Simple thing is without idli cooker, no idli. Simple. Similarly, without object, instance members don't exist. Either variable or method, instance variable or instance method. Now, memory is allocated for these instance variables and methods only after you create object. And now they exist. Understood, friends? Now, then you can say T1 dot. When I say T1 dot on this reference, you can see, can you see your A? Can you see your M1? These are, of course, part of these are static members. Still, we can see these are on these static members on object as well. But more than that, what is that we need? We need X. X is instance member. This comes to life. This comes to life only when you create object. And also M2. Somewhere you should find M2 also. You can see this come to life only when we create object. Maybe you can ask me, we are seeing few more else methods here. What are all this? We'll talk about them. These are methods of object class inherited from that superclass object. We'll talk. You don't need to understand this now. Ignore that. Your focus is only on X and M2, A and M1. These are shared members. Even though they are not part of object, these are shared. So even object also, as they are shared, we can see those static members under this reference. But that doesn't mean that they belong to object. They belong to class. Still, they can be shared by objects. Got it, right? Like a best example is library belong to the college, but still everyone go to library and share those books. So does library belong to us or college? You are joined in a college. Just a quick example. So library belongs to college but can be shared by every student. Something like this. These static members are like that. Even though they don't belong to object, still they can be shared by object. As in case of library. Even though it doesn't belong to us, it belongs to college, still can be shared by all students or teachers, everyone. So this is a quick idea. Maybe if you ask me a question, Manoram, you told static members are part of class but not part of object, then why we are seeing this A and M1 on this reference? These are shared members. So it's showing that. That's all, friends. All objects can share them. That's why they are visible. That's all. It doesn't mean that they are part of, they belong to object. Clear now? That's it, friends. I think I tried to be as clear as possible, and we have a very detailed differentiation between instance methods and static methods. Now you can say T dot X, T1 dot X. Now you can print it system dot out dot println T1 dot X. And then system dot out dot println. You don't need one more print. I'm just trying to call instance method T1 dot M2. You know how to call all this, right, friends? Okay. So here I'm seeing some error. Uh, Semicolon. Yes, sorry. Now let's run this program. So this is a simple examples for static variable, instance variable, static method, instance methods, differences. Right. Right click now, run as Java application. Now you can see the differences. Okay. So these are static members. So calling them in a static way. So these are calling static members. And this is calling instance members. Clear, friends, now? This is a quick idea and a simple program to differentiate between instance members and static members. Finally, one last question. One quick question is so why this main method is declared as static now? Now this is something people always ask in interviews. Why main is declared as static? Because when you start executing program, you see here now, let me just debug and so that you can clearly see that if the execution, the start of program. Now, if you see here while debugging, the execution starts from main method. Now, when you look at this execution, you can clearly say, what is your class name? Static demo. Dot main means why you can see this class name static demo is calling this main directly using class name. You can see we are not creating any object for main method, and in this execution trace, while seeing this execution stack here, it started with executing main by calling main directly using class name. Observe this clearly, friends. So this is possible because we have declared main as static. Otherwise, it's not possible, right? So JVM can call this main directly only directly using class name because main is declared static. This is the advantage what we have. This time you don't need to depend on object to call this main. Why? Because this is static. Once you start execution, you can simply say class name dot that main, and you can see a clear example here. I hope this is clear, friends. This is an important question in interviews. Why main method is declared as static? Because we can call it or invoke it directly without creating object, right? So this is the one more greatest advantage what we have when we declare a method as a static. But this is not recommended in every scenario or every situation. Hope this is clear to all of you. Can I get please share your are you clear with this, friends? Okay, are you clear with this? Should be. If I am not my from my this thing, I am very sure this is very clear for all of you. Just share me your feedback in the comments if you are clear. Okay, this is actually very important. Maybe you can think why this Manoram is taking this much time to discuss this topic, because these are all very core concepts. There are many people keep working in this industry without having this clear difference, right? So with this, I think one more topic is their access modifiers, right? So we'll discuss that, and then after that, the inheritance, polymorphism, all this doesn't take much time. You might think if you understand clearly what is class, what is variables, what are methods, all these at this level we have to spend more time. Once you are clear on these things, that other concepts of OOP are not quite difficult to understand, friends. You talk about inherited or polymorphism or anything. From here onwards, it will be very quick journey for us. Hope this is clear for you now. Right. So then next topic is what? This is the next topic comes is access modifiers. Once you understand all this, then you are a full package. Then you are ready to understand all other OOP concepts quickly. It doesn't take much time, right? There is a lot of confusion from many of our people. Still, they try to just spend time. They just work on them. Okay, but I don't want for us to have that situation. I want all of you to be very clear. So tomorrow when you start working with Selenium, you should not have that what shall we say, friends, confusion. That's all. So that's about all this. And still, if you have any questions, we can discuss. Now, access modifiers. I'll just give intro today, and then tomorrow we continue. Access modifier means what? These are again keywords, except default. Default is not a keyword. It's just only a access modifier, and in everybody's option somebody is there, that is default. Okay, now the point, what is access modifier? Access modifier tells about visibility of your members in your program. So access modifier tells about specifies. Okay, so there is a typo. Specify the visibility of members of a program. Visibility means what? Right? What is the meaning of visibility? If you can see something or not. Even for members of program. What are members of program? Members means classes, okay, or variables, or methods, or inner classes, okay, or enums, okay, or interfaces. All these are members of a program, okay. All this. Now the question is, if they are they visible or not. To understand this, you should have a clear idea about access modifiers. And here the visibility is with respect to package. In Java, we have to talk about visibility with respect to packages. I'll talk about what package is, but I'm just giving a clarity. So again, visibility. After this, we'll stop anyhow. Visibility is with respect to what package. It's all difference between one package and another package. It's like one village and another village. Suppose you are in some X village and some other person in Y village. Can you directly see that X person of X, so some person of X village, who is there in Y village? Means what is your answer? You are right now. You are in X village, friends. Suppose your friend is in Y village. By staying at your home, can you see your friend? Maybe I get this question is your friend visible from your home in your X village to Y village? What's your answer? Answer is no, because it's not possible, right? Unless we are somewhere in the sky and which we have some powerful vision this thing. Okay, vision tool only we can see your friend, right? Otherwise, he's not visible. That is what we call. Here you can assume package as the small village X and another village Y. Can we see one member of this X village and another member of Y village? Right? So that is what we are going to talk here. So that visibility means, simply speaking, let's ignore that village thing. I don't want to confuse you much. So here, can we see members of one package in another package? And if we should see, what should we do? What access they must have? That is the point, friends. Excuse me. That we see tomorrow. Right? We have four actually. That is public, private, protected, and default. We'll try to get a clear picture in tomorrow's session. But this is a quick idea. Access modifier tells about visibility of members of a package. In fact, maybe instead of program, let me correct it package. Okay. And these are all members. And visibility, we have to talk with respect to package here. And what do we have these access modifiers? Public, these are all keywords. Private, and this is also a keyword. Protected, this is also a keyword. Default, this is not keyword. Default is just only a namesake. We talk default access. If nothing, if you don't use any of these keywords, then the access is default. So anyhow, we talk about this four in tomorrow's session. So we'll just spend some 10 to 20 minutes to get a clear picture about it and switch to the another OOP concepts and try to clear this as quick as possible. Okay. Okay, maybe we need a couple of sessions to complete this Java and switch to Selenium. I don't want to stuck here with Java only, right? That's all, friends. Any questions, please stay back. We'll discuss, else we'll close this session. All of you are good friends?
Manoram, can you please post yesterday's and today's video in our WhatsApp group, please?
Yeah, yesterday's I have already shared Harish, right?
Vijay. I
Vijay,
can't
yes.
see. Yeah, I can't see. Maybe I'm.
I'll reshare, no problem.
Can you?
I'll reshare.
Okay, okay,
I'll reshare the list again. Okay.
okay. Thank you.
That's all, friends. Okay.
And just one small question.
Yes, yes,
Uh,
please.
why we are having these inner classes? A class means that we use set of methods and all that stuff, everything inside a class. But what is, I'm just looking at practical use of inner classes. Is there any use to use
Definitely,
inner
definitely.
class?
Yeah, definitely. Everything has a usage. Definitely, every construct we apply in any programming have a need and purpose, Vijay. Definitely. So when we
Yes.
talk about inner classes, actually they were class inside a class.
Yeah.
If again, it is also a kind of modularization. See, modularization happens in many ways, Vijay. One, by using classes, that itself is a kind of modularization.
That's correct.
Second level modularization happens with methods. That is one. Methods, right? Just
That's
now we
correct.
had.
Yes. Yes. Yes.
And there is another level of modularization. Suppose if you want to break down your logic, still you want to implement certain, still that logic needs a more elaborated implementation with some variables and methods that can be done with inner classes.
Mm,
So again, it is a kind of grouping, like it's a like subgrouping, you can say. Within a group, if you want to subgroup your members, suppose you have a shape example. In that shape, if you want to create a rectangle, you can make it a shape can be a class and rectangle can be inner class. You got it right?
okay. Okay. Okay.
And
Okay.
triangle can be inner class. And think one more, something else like quadrilateral can be an inner class. So what is
Okay.
that? When shape is outer class, you are grouping all that sub entities in a this what
Separate.
we call.
Separate class.
Yes,
Class
yes.
shapes. Okay. Okay. Okay.
You got this
Okay.
right.
Got it. Yes. Yes. I got it.
And there are many other uses. This is one scenario. Similarly, suppose if you want to provide a default implementation without constructing whole class, if you want to just simplify the way you implement your methods, then inner classes is also one way to simplify that creation. Suppose you
Okay.
see all these events in this UI related this thing. There is something AWT, right? Swings, all this which you are used to implement this UI scenarios, user interfaces. Generally, on
Okay.
user interfaces, you click on checkbox, you click on radio button, you click on your this button, normal button, right? So when you
Okay.
click on that, every time you click, some event should happen, right?
Action. Yeah. Yes.
Behind that, what they do is to trigger out these events for each this component. They create one inner class to
Code.
trigger
Okay.
this
Okay.
thing. You got it right.
Yes. I got it. I got
In
it.
that way, see, there are different purposes. It's not like we can limit this purpose of inner classes for one specific purpose. But
Okay.
these are all few examples for you.
Okay. Okay.
Is
Yep.
that clear to you,
Yep.
Vijay?
Yes. Yes. It's
Maybe
clear.
if you want, the best thing is because I have clearly observed the uses of this with this UI components in Java.
Mm,
But in majority of cases, I doubt if we use inner classes. But understanding that is very important. Is that clear?
okay. Okay. Yep.
Because if you are a full stack developer, then you deal with this UI components, right? Then this inner classes comes handy to you.
Uh,
Even in multi-threading, right? If you there are scenarios where we implement inner class object based inner classes.
okay.
Okay,
Okay.
all that.
Okay.
If maybe if you see one or two examples, you get an idea. But
Okay.
what I do is actually I don't have a plan to discuss much of inner classes, but as you raise this question, I'll just take few examples and show you. Okay.
Okay. Okay.
I'll just explain inner classes and then just give you a few examples so you get a clear picture, Vijay.
Okay. 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 Yep.
Understood now? I think
Yes.
this should be
Got it.
clear for now.
Yep. Yep.
Yeah. One or two examples. What we do is we'll talk about inner classes, not now. At the end of this concluding Java,
Session.
we'll
Okay. Yep.
discuss so that you get an idea. No issues. Okay, friends. That's about this one, Vijay. Uh,
Okay. Yep.
we'll
Thank.
take a few examples and see.
Okay. Okay.
Any other question, friends? Any questions? No, right? So then, if you don't have questions, we will uh,
Prompt.
stop here, friends.
Okay.
Yeah, bye.